Okay, so in this video we're going to have a look at modelling with quadratics, and as you can already see on the screen, these questions are pretty lengthy, but this is the type of question that we're going to learn how to answer. There's a lot of words in these questions and a lot of mathematical skills that you actually need to know, such as solving a quadratic, understanding how a quadratic looks and can be sketched. You need to know how to use the quadratic formula, you need to know how to complete the square, both with positive and negative quadratics, and you need to know how to interpret all of that information and understand things like the turning point. So there's a lot of topics involved in this, and I am going to link them all in the description. So if you're not sure on any of those ones that I just said, obviously go into the description and check those out. Although as I am going through the video, I will indicate sort of where a particular topic is involved, and obviously direct you there to go into the description and have a look at that particular topic if something is going a little too quick for you. But we're only going to look at 4 questions. I'm going to do one, you're going to do one, that sort of style. But this is the type of question we're going to be aiming to answer, and another type of question in a slightly different context. So that's what we're going to be having a look at with modelling quadratics. And with that being said, let's get started. Okay, so looking at our first question. Now I would encourage you to obviously just pause the video, have a read of this question before we start going through it, because there's a lot of information, a lot of questions, and a lot of things that are probably just worth reading before we actually get started. So I'll give you an opportunity to do that now. Okay, so a javelin is thrown over level ground from the top of a tower, and the height in meters of the javelin above the ground after t seconds is modelled by this function. So we've got the function here for t, and it says 12.25 plus 14.7t minus 4.9t squared, where t is greater than 0. There we go. So it says here, interpret a meaning of the constant, and then it starts to give us some more questions. So what we're actually going to have a look at is just thinking about what this would look like in terms of a function, in terms of a quadratic, and sketching that, and then we'll have a look at answering all of these little questions. Now before we do that, I'm just going to make this a little bit smaller, so hopefully maybe you've made some notes on that, you've written it down, because this is going to be a little bit harder to read because we need quite a bit of space. So I'm going to push that to the side, and we're going to carry on looking at it from here. So if we were going to draw a little sketch of this, and we kind of imagine what this would look like on a graph. So if we draw a basic little axis, and it does only have to be a little sketch here, you don't really even have to draw this, but it does help us just to visualise it. So we're standing on the top of a tower, and let's imagine that's on the y-axis there, and we're throwing a javelin. Let's just say this is the top of our tower, and we're going to throw that javelin, and let's go for a different colour, to the right, and that is going to make a nice quadratic curve, and it's going to land somewhere down there. Now obviously if we were going to model the entire quadratic, the actual curve itself would continue, but obviously we know here we're throwing it forwards off the tower, so we don't really need to know about that, but it does help us just to kind of visualize what's going on. Now if we look at the actual function here, we've been given a load of numbers. Now we should already know from sketching quadratics and just knowing about coordinate geometry and our line equations that one of those numbers there is our y-intercept, and it's the constant number, so not the t squared or the t, but the 12.25. So that 12.25 there in our function indicates where it crosses through the y-axis, and in the case of this question that is actually indicating the height at which it is thrown from. So that's 12.25. Now straight away that actually answers part A for us, because it says here, interpret the meaning of the constant term 12.25 in the model. Well, that is the height of the tower, or in other words, the height at which the javelin is going to be thrown from, and in this case that is the height of the tower. So that's the answer to part A, it's going to be the height of the tower. Let's have a look at part B. It says, after how many seconds does the javelin hit the ground? Now obviously if we're looking at how many seconds it takes for the javelin to hit the ground, we first need to just think about the axes here. We already know that 12.25 in terms of this diagram is our height, so we can label that axis as h, and our other part of the axis is going to be our time. And obviously we could label that as t, which is given as in the question, and that time is in seconds. So if we want to find where the javelin hits the ground, we're looking at specific points on this quadratic, and specifically we're looking at the solutions, these points here, and obviously this point here if we were to go backwards. They're the two key points, but we're obviously looking for that positive one if we're throwing the javelin there to the right. So in order to find the solutions, what topic do we actually need to know? We need to know obviously how to solve a quadratic, so that could be down to either factorising to solve it, or it could be the quadratic formula. Now looking at the numbers that are given to us in this function, it's going to be a lot simpler for us to use the quadratic formula, particularly as you would have a calculator for this question. So really, in order to find that number, we just need to type these numbers into the formula. So first of all, we just want to write down what the values of A, B and C are in order to put that in. Obviously, if you have some of the fancier calculators, you can actually just type those numbers and it will give you the solutions, but we should know how to use the quadratic formula, and I'm not going to assume that everybody has one of those calculators where you can do that. So for part B here, let's just write down those values. So the value of A is the coefficient of t squared, which in this case, and if we'd highlight it, is negative 4.9. So our value of A is negative 4.9. Our value of B is going to be the positive 14.7 in the middle there. So B is 14.7. And our value of C is the constant at the end, which is actually at the start of ours, but 12.25. So at this point, obviously, you do need to know the quadratic formula. So again, I'll link that in the video. And if you need to have a look over the quadratic formula, please do feel free to do so, and then come back to this. So plugging this into our formula then. So we've got minus b, so minus 14.7 plus and minus the square root of b squared. Now b is not negative, so I won't worry about putting it into a bracket, but 14.7 squared, and then minus 4ac. So we have to extend that because we've got quite a lot going on here. So 4 times a is negative 4.9, so times negative 4.9, times c, which is 12.25. There we go, just about fit all of that on the screen. And that's all over 2a. So all over 2a, a is minus 4.9, so 2 times negative 4.9. So typing that all into the calculator, once with the plus sign, and if you type that in with your plus sign, so just indicate that by putting a little plus there, we get the answer negative 0.679. Now obviously we know it's not going to be minus 0.679 seconds, so we're going to have to go back into the formula using the minus sign, and let's do that now. So back into the calculator, take away the plus, put in your minus, and we get here 3.679. So there is some more decimals there, but I'm going to leave that as 3 decimal places, or I could say 4 significant figures. There we go. And again, you could leave it as 2 or 3 significant figures, but obviously just write down the way that you're rounding it there, particularly when it doesn't ask you how to round it in the question. So there we go, that's going to be part B for us. It has to be that positive value there, so our value is going to be 3.679. So you've already seen with modelling quadratics, there's already one extra or additional topic within this that we're going to need to use in order to solve them, if we are in a question where we do need to find one of those solutions where it's crossing over the axes. So that is part B. We have found after how many seconds does the javelin hit the ground? Well, after 3.679 seconds, and that is the answer to part B. Now we're obviously going to have a look at part C. So let's get rid of some of this working out, because we're not going to need all of that. We'll keep the answer on the screen, but we'll get rid of all this quadratic formula and everything, and we'll just keep a fresh eye for this next question. There we go. Right, let's just move this up a little bit. There we go, and we can say that that there was part B. Obviously don't rub your working out in when you're doing this, but for the purpose of fitting all this on the screen, we'll go from there. Okay, so for part C, it says write the function of t here in the form a minus b brackets t minus c squared, where a, b and c are constants to be found. So hopefully you are recognising that there, and that is completed square format. So we do have to complete the square for this quadratic. Now obviously that involves you being able to complete the square for harder quadratics, and in this particular case you need to complete the square for a negative quadratic. And I mentioned that at the start of the video, and if you're not entirely sure on completing the square when we're doing this for a negative quadratic, again, please do go into the description, check that topic out, and then come back here and make sure that you're okay with obviously completing the square for a negative quadratic. So in order to do this, I think the easiest way, and there are obviously some slightly different ways of approaching completing the square, but I'm just going to rearrange this quadratic so that the t squared is at the start. So if we just move that piece to the front, that would be minus 4.9 t squared. We've got the plus 14.7t in the middle, and then we've got a positive 12.25 at the end. Remember, we're not rearranging rearranging it to the other side of that equal sign. We're literally just moving them into a position that looks like a normal quadratic. So from this point here, we obviously need to take the coefficient of t squared out, and in this case that's the negative 4.9. So we're going to divide everything by negative 4.9. Now don't forget you've got a calculator, so although the numbers don't look very nice, it's relatively simple to do that. You just need to divide all these pieces by the negative 4.9. And when we write that, we put the minus 4.9 on the outside, open up a bracket, and then we'll divide everything now. So we'll get t squared, and again you're just typing this in on the calculator. Feel free to type it in along with me. 14.7 divided by negative 4.9 will come out as minus 3, so minus 3t. And then 12.25 divided by negative 4.9 comes out as negative 2.5. And there we go, our quadratic is now in a position where we can complete the square. So opening up a new set of brackets, so we can just complete the square in the middle. We've still got the negative 4.9. And again, there are different ways of approaching this next step. I like to just complete the square as we always did at GCSE level. So, completing the square, halving the coefficient of t there would give us minus 1.5 in brackets squared. If we expanded that bracket, that would give us positive 2.25. We don't want positive 2.25, we want negative 2.5. So in order to complete that squared bracket, I would have to subtract 4.75. And again, you can work that out on a calculator. Hopefully you can spot that though, that to get from positive 2.25 back to negative 2.5, we're going to have to take away 4.75. And there we go, I can close my bracket. Right, so at this point, again, we're running out of a bit of space. So I'm going to get rid of that first bit of working out. And we're just going to go from this position that we're in at the moment. There we go. So at the moment, we have these particular pieces. We've got the minus 4.9 on the outside, and we're going to have to multiply that back in so that we can have a look at those particular elements. So let's multiply the negative 4.9 back in, which just means it goes at the start of the squared bracket. So minus 4.9, open brackets, t minus 1.5 squared. And then obviously we need to multiply that constant at the end by the negative 4.9. So negative 4.75 on your calculator multiplied by negative 4.9 gives us positive or plus 23.275. So there we go, we've completed the square. Not a nice one, but obviously do check out completing the square and my negative quadratics video if you're a little bit unsure on that. And obviously in the question, again, let's have a look at this. Let's just highlight that again. In the question, it did ask us to write it in a particular form, and it wanted it as a minus and then the completed square bracket there. So we just need to obviously slightly rearrange this. We're going to move that 23.275 to the start just before the negative 4.9, and that would then read 23.275 take away 4.9 brackets t minus 1.5 squared. And there we go, and that is in the form that the question's asked us to do, and we've completed the square and we've completed that question. Now you might be asked for obviously what the constants a, b and c are, and if you are, you've got them right there. You've got a is 23.275, b is 4.9, obviously because minus the negative was already in the question there, and c is 1.5. Again, the negative is already in the way that it's written, so c is just 1.5. Right, there we go. So that is part C. Again, for the next question, for part D, we're not going to need all the working out here, so let's just get rid of that working out. Again, hopefully you're writing this down as you're following along. And there we go, get rid of all those little pieces. And there is part B. Sorry, part C. There we go, move that up. Right, on to the last part then, part D. And the good thing about these questions is part D is usually always using one of the previous parts, and this one actually tells you which part it wants you to use. So it says using your answer from part C or otherwise find the maximum height of the javelin above the ground and the time at which the maximum height is reached. Now in order to understand this, you just need to understand turning points of a quadratic and what actually completing the square finds for you. Now if we think back to our diagram, the turning point is the highest point, this point here on the top of the curve, where it stops going up and it starts going down. And that is found by reading the numbers inside our completed square form. And specifically, we read the number in the bracket for our x coordinate and the number at the end, the constant there, for our y coordinate. So if we actually wanted to label this as a pair of coordinates, not forgetting that the number in the bracket, the sign is going to change there. So it's not going to be negative 1.5, but it'll be positive 1.5. So this turning point coordinate would be 1.5 and 23.275. Again, if you've forgotten that, I'll stick that link in the description for completing the square as well. Just a little reminder from GCSE level. So we've got all of our numbers. Let's see how we apply that. So it says using your answer from part C or otherwise find the maximum height of the javelin. Well, the height is our y coordinate. So the height there, I'm just going to write this as height. And this is question D. So for the height is our y coordinate, which is 23.275, and the question is in meters. So I would say 23.275 meters. For the next part, it has also asked us to find and the time at which the maximum height is reached. And the time there is our x coordinate. As you can see along the x-axis, that was our time, and that is the 1.5. So for the time, it's given to us in our coordinate there, and that is 1.5. Looking at the units in the question, the units are seconds. And there we go, and there's our question completed. So as you can see, there was a lot of topics involved there. We had sketching the quadratic, not that that was essential, but it does help just to visualize the question. So sketching a quadratic, we had using the quadratic formula, we had actually in part A reading the y-intercept and understanding what that meant. We had completing the square and doing that with a negative quadratic in this question, and then obviously interpreting that and looking at the turning point. So lots of topics there, lots of things that you can go into the description and have a look at, but that's our practice question. Let's have a look at one for you to have a go at. Okay, so here's your question. It's quite a tricky one. There is a particularly nasty little bit in part D there where something's a little different to what we've gone over. So I would suggest pausing the video, having a good read through this, probably writing it down, and then obviously restart the video and we'll start going over the answers. Okay, so to go over the answers for this, first of all, we're just going to push all this to the side. And here we go, we'll start going over it. So it says in this question, an archer shoots an arrow and the height h meters of the arrow above the ground is modelled by the formula. And it gives us our formula here. So it says that h is equal to 1.8 plus 0.4d, take away 0.02d squared. So we've got some pretty nasty numbers in this. And if you've obviously already read this, you'll already have seen in part C, it asks you to write it into completed square form. So we had a pretty nasty coefficient of d squared to take out there. Although we are doing it all on a calculator, so it actually isn't too bad. So let's have a look at actually answering this. So it says in part A, interpret the meaning of the constant term 1.8 in the formula. Now it can really help here if we draw a little diagram. You don't necessarily need it for part A, but it is quite a nice little diagram to draw because it fits in quite nicely with the context of this question where we are throwing or shooting an arrow. So if we actually interpret the meaning of the constant term 1.8, that is actually in relation to the y-intercept. And obviously if we look at the y-intercept in terms of a little diagram here, we think about what this would look like. It starts at 1.8, we've got a nice negative quadratic where the arrow is flying, and then it would land over here somewhere, and we can extend that into that negative region there. But if you think about the 1.8, which would be just here, what does that actually mean in relation to this idea? So in relation to this, the 1.8 there is actually the height at which the arrow is shot from. Okay, so the height at which the arrow is shot from is the 1.8 in this diagram. So that's part A done. Or we could write the height of the arrow, or the height at which the arrow is shot from, and that would be our 1.8. On to part B, it says find the horizontal distance travelled by the arrow as given by this model. Now in order to find the horizontal distance, obviously like before, we are looking at those solutions. And we have two solutions to this quadratic. We've got the one over here, which is where the arrow lands, assuming we're shooting it to the right there, which we are. And we've got the negative solution back here, which obviously we're not really too concerned about, but we are going to get two solutions when we're going to solve this. So in order to solve this for part B, we are going to use the quadratic formula. And again, if you've got a calculator where you can type in the values of A, B and C, you can get your answers pretty quick, but we should be able to use the quadratic formula for this. So looking at our quadratic, and again, it can help to rearrange and rewrite it. Obviously, we can do that for our completing the square too. But if we rearrange it now, we would get our coefficient of d squared to start with, which is negative 0.002 d squared plus 0.4d, and then the number at the end, our constant 1.8 plus 1.8. So our values of a, b and c we can write down straight away. We've got that a is equal to a negative 0.002, b is equal to 0.4, and c is 1.8. Now, rather than writing all of the quadratic formula down, because we've already gone over it, we'll just put that straight into the calculator. So putting that into the calculator, pressing equals on our quadratic formula, not forgetting to put brackets around the value of b, even though it's not negative, not forgetting that negative b is going to be negative 0.4 at the start there. But if we type all of that in, we get two values. We either get that d, the distance, is equal to, and we get negative 4.4, or we get the answer 204.4, again just rounding that to one decimal place. So 204.4 there is going to be our answer. That is the positive value, and obviously that makes sense in terms of our diagram. Now the question, let's not forget, that is the distance measured in meters, so that is going to be 204.4 meters. Okay, so not forgetting to give you units as well. Right, there we go. So that is part B, and now we'll have a look at part C. So it says for part C, write H, our formula there, in the form a minus b brackets d minus c squared, where a, b and c are constants to be found. So that's obviously asking for us to find the completed square form of this particular model. And if we're going to find the completed square form, let's just have a think about that. Let's move some of this out of the way so we've got some space. There we go. And we'll keep part of B on the screen, and we'll just focus on completing the square. So for part C, let's have a look. Now we've already rearranged that quadratic, so to be fair, could have done with leaving that there, but there we go. We're going to want to rearrange it because we want to take out that factor of negative 0.002. So if we rewrite that quickly, we've got negative 0.002 d squared plus 0.4d plus 1.8. So in order to complete the square, and obviously don't forget to check out the revision videos on that, we need to take out that factor of negative 0.002. So negative 0.002, and then in the brackets we get d squared. 0.4 divided by negative 0.002 is, let's have a look, we get 200, so negative 200d, and then positive 1.8 divided by that negative 0.002 gives us minus 900. And that is now in a format where we can actually complete the square. So completing the square, we need to halve that coefficient of d. So keeping our factor of 0.002 on the outside, we'll open up a second set of brackets, and then we'll complete the square inside this. So we've got d minus 100, half of negative 200, that's squared. When we expand that, that would give us 10,000. Which you can write down to the side if you want, at the end, and we want to get back to negative 900. So we're going to have to take away 10,900 in order to get back to that, closing our brackets. There we go. Now, one more step to finish this, because we need to multiply that negative 0.002 back in. So we'll have negative 0.002 in the brackets, d minus 100 squared, and then we need to multiply that negative 10,900 by the negative 0.002. So on the calculator, I've just realised I forgot to put the bracket in there, so let's correct that. There we go, put our bracket in. And when we do that negative divided by the negative 0.002, we get positive or plus 21.8. Right, there we go. So we're almost done. It's not quite in the format that it was asking for. It does want us just to slightly rearrange that because we want that 21.8 at the start. So if we get rid of these pieces, because we're not going to need those for the next question either. There we go, let's get rid of all of this. And we just want to rearrange that just to finish this off. And then we can have a look at our final part there. So moving that up to here. And all we've got to do is rearrange it. So this is a nice easy step. Move the 21.8 to the start. And then we're going to take away the 0.002 in brackets d minus 100 squared. and just obviously make sure that matches up to the form that you've been asked for, which was a minus b brackets d minus c squared. So a was 21.8, b was near 0.002, and the c was 100. And there we go, that's our final answer, so we'll highlight that to finish. Right, there we go. So that's the final part. We now have part D. That's what's interesting, because it says it is decided that the model should be adapted for a different archer. And we know with different archers, obviously people will have different heights, and that is highlighted to us in our new formula, because instead of having 1.8 at the start, we've got 2.1. So right at the start there, we've got that 2.1 that we need to take into account. Okay, so that number there. So it says, hence or otherwise find the maximum height of the arrow above the ground and the horizontal distance from the archer of the arrow when it's at its maximum height. So in order to do that, all we really have to do is think about the current piece, or the current quadratic that we're looking at. So if we look at our current quadratic, okay, because this doesn't make any assumptions that the other archer is necessarily stronger or anything like that, because the rest of the formula hasn't changed, it is literally just their height that's changing. And if it's just that their height is changing, then that's fine. We can use our current model and we can just factor in the extra height of the other archer. And if we have a think about that, the other person was 1.8 meters and this person is 2.1 meters. So there is an extra 30 centimeters to add on to our answer. And we'll add that on at the end once we've got it. So thinking about our model here, at the moment, looking at our completed square form, we've got the coordinates of the turning point, and the turning point would be up here, and we take that from our completed square form, and we've got our x coordinate here, which we flip the sign, so that's going to be 100. So just down here in the middle, that is 100, and the height of that is our y coordinate, which is 21.8. There we go, and that is on the y-axis there. So our height, which obviously is not to scale in my diagram, but that height there is 21.8. So thinking about how this relates to our question, it says find the maximum height of the arrow above the ground. Well, the current height with the 1.8 meter archer would be 21.8 meters, but we've got the extra height now, the extra 0.3 coming from our new archer, so we need to add 0.3 to that, and it gives us our new height, which would come out as 22.1 meters for the height. And then we also need to look at the distance. Now the distance there is not going to change. So for the horizontal distance that arrow is going to meet the maximum height, we've already got it on our diagram. It's 100 meters right there in the reflection point of the curve. So our distance, and we'll write this down as distance just to differentiate those two. So the distance will be that original 100 meters. And there we go, and that's finishing off that question. So 4 parts to that last part there added in that extra element of the model slightly changing the height, which slightly adapted our turning point there, but absolutely fine. Hopefully you found that okay. Right, let's have a look at a different type of question. Okay, so on to our next question. Now again, there's a lot of words here, so I would advise you pause the video and write this all down and have a good read through, but I'm going to assume that you've done that now, so we're going to carry on and have a look at this question. So it says an arena has 25,000 tickets. They know from past events they're only going to sell 10,000 if the ticket costs £30. They also expect to sell an extra 1,000 tickets for every time the price goes down by £1. And the number of tickets sold given by T can be modelled by this linear equation, T equals M minus 1,000p, where P is the price of each ticket in pounds there, and M is a constant. And for starters here, it wants us to find the value of M. It then goes on to want us to write it in completed square form and use that completed square form to think about that turning point again, looking at the maximum amount of money they could charge, or the most that they could charge in order to maximise their amount of money. So obviously I'm hoping that you've written this down, you've had a good read, so we're going to move everything to the side. And here we go, now we can get on with answering the question. So looking at this one then, for starters we've got to find the value of M, and we're given this equation T equals M minus 1,000p, and it says that, let's make sure that's 1,000, and it says that M is a constant. So we've just got to find out what that number is really, so we need a value of T and a value of P in order to solve that. And if we read our question here, we've been given one of those values. T is the amount of tickets they expect to sell, and we've already been told they know that they're going to sell 10,000 tickets, but on the basis that each ticket costs £30. So we have a value of P as well. So all we actually have to do to find the value of M is sub those values into our equation. So if we put them in, T is 10,000, so 10,000 is going to equal M minus 1,000 multiplied by, which I'll put in brackets, 30. So let's just look at that and expand that. So 10,000 is going to equal M take away 30,000. And hopefully you can spot straight away there that value is going to have to be 40,000, because 40,000 take away 30,000 will equal 10,000. So for part A, I'm going to write this over here so it stays on the screen. M is equal to 40,000. There we go. So we've got our value of M. Okay, so moving on to part B, it says we have the total revenue R can be calculated by multiplying the number of tickets sold by the price of each ticket, and this can also be written as R equals P brackets M minus 1,000p, this information just there. Obviously we can expand that, it's just given to us in a bracket to start with, and it wants us to rearrange it into the form, and then it wants it in completed square form. So in order to do that, we just need to expand that bracket and go about rearranging it into that completed square form. And if we do that, let's get started and move all of this out of the way. First of all, we just want to expand that bracket. So let's go about expanding the bracket. So we'll get R is equal to MP, and again, you could put the P first, but we've got the P at the end on the next P, so I'm just going to keep that consistent. MP minus 1,000 P squared. Now we already know from part A that M is 40,000, so we can put 40,000p rather than MP. I'm going to get rid of the R equals for the moment, just so we can actually look at completing the square for this. So at the moment we've got 40,000p minus 1,000p squared. And notice that we obviously no longer have a constant here, so when we complete the square we just need to watch out for that as well. So let's rearrange that so that the p squared is first. So we have minus 1,000p squared plus the 40,000p. There's a lot of zeros here. There we go, 40,000p. And to complete the square, we need to take out a factor this time of negative 1,000. Not forgetting you've got your calculator, so that's not too bad. So we'll start off by taking that factor out. So if we do that, we've got minus 1,000 outside the brackets. And in the inside here, we've got p squared. That's now going to be minus, and 40,000 divided by 1,000 is 40p. There we go. So now we just need to complete the square. So go about completing the square for that. We're going to introduce a new set of brackets. So minus 1,000, and then we'll complete the square. So halving minus 40 gives us minus 20. In brackets squared. If we were to expand that bracket, we would have plus 400, and we obviously want to get back to 0, so we just want to minus that 400, and that's going to balance out and complete that square there, and then closing off our bracket. Okay, so we've pretty much finished. All we actually have to do now is multiply that 1,000 back in, and if we multiply that back in, let's see what we get. We get minus 1,000, lots of the p minus 20 squared, and then negative 1,000 times the negative 400 gives us plus 400,000. There we go. So we've got it in completed square form. Obviously the question wants it written slightly differently, though it does want that 400,000 at the start. So in order to do that, let's get rid of all of this, and we'll just write it in the correct way, and then we can have a look at part C without all of this information everywhere. So that is our second to last step. We just need to write it in the correct form, and that correct form is going to be 400,000 minus the 1,000 p minus 20 squared. There we go. So that is part B. It's in the form that it wants, and we could say that A is 400,000, B is 1,000, and C is 20. And now we can actually look at part C. So let's just label that as part B, and here we go, part C. So it says using your answer to part B, or otherwise work out how much the arena should charge for each ticket if they want to make the maximum amount of money. And again, you don't have to draw a quadratic for this, but it fits in nicely, just obviously thinking about what a quadratic looks like, and it just helps us to visualize it. So if we think about this, we have T going up here, which again, always refer back to the question. T was given to us at the start, and it says, where is it? T is the amount of tickets sold. So the amount of tickets sold is up the top, and along the bottom here is going to be our price, which is obviously what we're looking at right now, the price of the ticket. So we already know that in our completed square form, we've got our constant right there, and we have our 20. So that gives us the coordinates of the turning point. So if we think about what this would look like, we'd have some form of quadratic. We're going to have to sell some tickets. But again, we could sell 0 tickets if the price was incorrect. But if we were to draw a quadratic, we don't know exactly what it's going to look like. Let's just imagine it looked like this. And we would be looking at this particular point just here, where the amount of tickets is maximized and it's not going to start going back down because we've put the price too high. So for this one here, let's have a think. We've got 20 there as our x coordinate, not forgetting to flip the sign. So 20 and 400,000 for our y coordinate. There we go, so 400,000. There we go. So on the y axis, we'll just about fit that in, 400,000. Just about fit that in, and the price down here is going to be 20, and that is where we maximize the amount of profit that we're going to get, or they maximize the amount of money for each ticket right at that turning point. So the price that we've got there is £20. So the price that we want to sell our tickets for is £20. After that, the amount of tickets that we sell is going to start to go down. Okay, obviously the quadratic isn't going to look exactly like that, but it's just a visual example of looking at the turning point and thinking about obviously the point at which it starts to go back down again after the price has increased too much. Obviously, if we put the price as 0, we'd expect to be having a lot of tickets sold, so it wouldn't look exactly like that, but it's just a nice little visual reminder. So there we go, that is how to complete these sort of questions and how to just draw a little diagram just to help yourself visualise the turning point. So here we go, let's have a look at a question for you to have a go at. Okay, so moving on to our final question. Now, as with all of these questions, there are slight differences between them all, but this one is very closely linked in terms of its context to the previous question that we looked at. So have a read of this video, pause it here, and then have a go, and we will go over the answers in a second. Okay, so looking at this question then. So in order for us to actually go over this, I'm just going to push all of this right into the side. So let's have a look at that. And now we've got a bit more space to actually go about answering this question. So looking at this question here, it was quite an interesting one. It said about a company makes a type of children's toy, and the annual profit was modelled by this equation. Now what was interesting was that this equation was actually given to you in completed square form. So obviously we can think about what that would look like in terms of the quadratic, and actually figure out some of the turning points already straight from the way that it was given. So it says here P is the profit, and that was given to us in thousands of pounds, and X is the selling price just in pounds. So using the model, explain why £15 is not a sensible selling price for the toy. Well, if we actually take £15 and actually substitute it into our model, let's have a look at what that profit actually comes out as. So putting £15 in, and remembering that X here is given to us in pounds, so we can just put the number 15 in. And if we sub that in, so for part A, let's see what we get. So we've got 100 minus 6.25, and that's going to be multiplied by 15 minus X, so 15 minus the 9, so X minus 9, sorry. So that'd be 15 minus 9 squared. And if we type that in on a calculator, we get the answer negative 125. So there we go, that would not be a sensible selling price because obviously a negative number here results in a loss. Okay, so we'll just write this, price would result in a loss. Okay, there we go, and that's our answer to part A, in a loss. Perfect, that's all that you'd need to say for a question like that. Moving on to the next part, it says, given that the company made an annual profit of £80,000, find according to the model the least possible selling price for the toy. Okay, so looking at this one then, now we've already got it in completed square form up there, so obviously we can use that form to compare that to 80,000. Now it says obviously that given that the company made an annual profit of £80,000, so we can put that in, and we've just got to be careful because the profit aspect here is given in thousands. So that 80,000, when we put that into our profit, we would only write the number 80. As it says up there in the question, P is the profit in thousands of pounds. So when we put that in, we could put it as equal to, but we want to have a look at making sure that we are above the 80,000 according to our model. So if we write this, we're going to write this as an inequality. So taking our completed square form, we could say, okay, well 100 minus 6.25 x minus 9 squared has got to be greater than 80. And obviously we just need to go about solving this. So to solve this, we obviously just want to rearrange it. So if we first of all subtract 100 from both sides, and if we minus 100 from both sides, we'll end up with minus 6.25, not forgetting that negative there, x minus 9 squared, and that's now going to be greater than negative 20. Now that negative is going to disappear because the next thing that we need to do now is divide by negative 6.25. Again, don't forget you're just going to do this on the calculator. So we'll divide by negative 6.25, and let's see what that results in when we get that. Swap colours again. We get x minus 9 squared is now going to be greater than negative 20 divided by negative 6.25, which is positive 3.2. Right, so we're almost done. We've just got two more steps. We need to get rid of that squared and then move that 9 over. Now this next step is quite important. Let's not forget when we square root both sides, we've got to take into account the positive and negative value of us when you square root a number. So we will have x minus 9 has got to be greater than positive and negative root 3.2. Okay, very, very important now. Obviously, we're looking at solving via completing the square. Again, I've got that video linked in the description, so you can always have a look at that if you're not too sure. On to our final step then, we need to add the 9 over. That's up to you. You can put the plus 9 after the root 3.2. I tend to put it just before the plus and minus, just because it looks a little bit nicer. But if we stick that in by adding the 9 over, we've got x has got to be greater than 9 plus and minus the square root of 3.2. And there we go. Now we have got our final answer here, but we just need to consider these values in terms of which one we actually want, because the question did say find the least possible selling price. So in order to get a selling price of greater than 80, it has to be between these two values. So if we get rid of part A here, so we finish with that, and let's just have a look at how we would finish off the answer for this question. There we go, we can just about get rid of everything there. Okay. There we go. So if we're going to write this as an inequality, we put it as a joint inequality between these two values. So we just need to think here, which of those values is the lower of the values? Well, is it going to be 9 add the square root of 3.2 or 9 take away the square root of 3.2? So it is going to be the 9 minus root 3.2 that is our lower value, and 9 plus the square root of 3.2, which is our larger value here. So if we want to find the least possible selling price, well, clearly we want the least possible value there, which is going to be our 9 take away the square root of 3.2. So if we stick that number into the calculator, so 9 take away the square root of 3.2, that gives us an answer of 7.2111, and lots of decimals here. So obviously we're talking about money, so we want to actually round this to the nearest possible amount of money here, which is going to be to the nearest penny, but you've got to think carefully. If we round this to the nearest penny, that's going to be £7.21. But it says here our lowest possible selling price is just over £7.21. It's £7.21 with that extra 1 and the decimals after that. So in order to make sure that we get the correct amount of money here, we're actually going to have to round that to £7.22, that next penny up, because £7.21 is actually under our lower limit by a fraction of a penny, but it is under, so we have to take that into account. So for that answer there, our lowest possible selling price is going to be £7.22, and that is our final answer. Again, just solving there using completing the square. Now, we've obviously got a final question here which says the company wishes to maximise its annual profit. State according to the model the maximum possible annual profit and the selling price of the toy that maximises that annual profit. So for this particular question, all we actually have to do for this is think about what the actual quadratic would look like here. Now, in this question that I've given you, you haven't actually been given a diagram. Now, when a question like this did come up, it was actually given to you with a diagram, okay? But we didn't actually need it for the purpose of these questions, and we don't really need it for the purpose of answering this question. But it does actually help just to be able to see exactly what it looked like, because it gives us a bit of a better view of what we're actually looking at. So if we get rid of all of this, And again, feel free to obviously just go back, write any of that down that you needed to. But we're just going to get rid of that and have a think about what this would look like in terms of the graph. So if we draw this out, we obviously need to have a set of axes. And if we draw a set of axes and think about what it would look like, we would have a quadratic curve going up. It's a negative quadratic, so it's sloping in that U shape, and that would be our quadratic. Now looking at the actual function, which is obviously given to us as the profit is equal to 100 minus 6.25 x minus 9 squared, we can think about, in terms of completing the square, what does this actually mean in relation to our turning point? So we already know from previous questions this constant in here is our y coordinate of the turning point, and we know that the number inside the bracket, which in this case is -9, helps us to give our x coordinate. Obviously we need to flip the sign, so the coordinates of our turning point, and let's label them on here, would be +9 and 100. And thinking about what that means in terms of the x and y axes, we would have 100 over here, and in the middle, down at the bottom of the quadratic, right in that reflection line there, would be an x coordinate of 9. So we've got our numbers that obviously maximise our profit and give us our selling price at that particular point, right at the peak of the curve, right at the peak of the parabola. So those numbers are 9 and 100. We just need to get them the right way around. So in terms of, and let's have a look at the question, our possible profit and the selling price, well, our possible annual profit, not forgetting that that number 100 is given to us in thousands of pounds, the maximum possible annual profit would be £100,000. There we go, which would make sense, obviously, given the context of the question here, because if you look at that completed square form, in order to make sure that we don't take anything away from 100, just here, we want everything after the 100 to equal 0, because obviously ideally we want it to say 100 take away 0 for our profit. We don't want to take away any of that 100,000. So in order to get 0, we would have to put the selling price into there of 9, because then in the bracket it would be 9 take away 9, which would give us 0. And that obviously links back to our graph there, which gives us our selling price, and let's just highlight that in the question, the selling price of the toy, and the best selling price for the toy that maximises the profit is £9. Okay, as backed up by the equation that we're given in completed square form, and backed up when you have a look at the graph there, looking at that turning point. So there we go, that was our last question. Lots to think about there, lots of videos that you might need to go and check out in the description, but hopefully that was helpful and useful. If it was, please like, please comment, please subscribe, and I'll see you for the next one.